Hi, everyone. I am Lindsay Kittendoff, Director of Communications at Vectra AI. Today, I'm joined by Vectra AI Principal Security Researcher, Kat Traxler. Hi, Kat.
Hey, Lindsay.
Hi. So today, Kat and I will be chatting about a really important topic, insecure by design flaws. So unlike vulnerabilities that emerge from coding errors or misconfigurations, insecure by design flaws are baked into the very architecture of a system, protocol, or device. They're not accidents. They're often the result of legacy decisions, performance trade-offs, or convenience over security. The problem, these flaws create persistent, hard to fix security gaps that attackers can exploit, sometimes without even needing to bypass traditional defenses. So, Kat and I will be talking today about what makes these flaws so challenging, why they continue to exist in modern systems, and most importantly, how security teams can identify, remediate, and mitigate the risks they pose. So, Kat, let's dive in. To level set, my first question: how are insecure by design vulnerabilities different from traditional software vulnerabilities?
Yeah, thanks for that question, Lindsay. It can be a little nuanced. Traditional software vulnerabilities, you can often pinpoint the issue to a single line of code. You can scan a software package and you can say the software package has the vulnerability in it. With insecure by design flaws, frequently you can't pinpoint a line of code that's bad. Oftentimes, it's an architecture that has some bad assumptions. It's often just an approach that a system took that has some flaws in it, and that presents quite a few bigger challenges around addressing and mitigating them. Um, there's also the issue of feature abuse, which I like to highlight because when people think about issues in the cloud specifically, people think a lot about bad actors using the cloud for their own use, for their own misuse. And while these insecure by design flaws have the same sort of flavor as a feature abuse,
Mhm.
ultimately feature abuse can be remediated. You can redesign a system to bypass these flaws. Or feature abuse, it's sort of inherent to the system. You might have 20 or 30 different types of feature abuse within a cloud service provider that's always just inherently going to be there. And bad actors can use those features for their own ill-gotten gains.
Okay. So, why are insecure by design vulnerabilities particularly challenging to remediate in cloud services specifically?
Because often the customers are going to be relying on those features in their day-to-day operations. And there might be a bad assumption. There might be some overprivilege that's baked into the system. But when they're introduced and customers start using them, all of a sudden we're reliant on those for operations to go about their business. And it's not as simple as updating the platform and switching to a new code base. In order to remediate these things, a lot of times you're going to have to redesign systems. You're going to have to redesign whole processes. So it takes a lot of coordination between the customer and the cloud service provider.
Makes sense. So, what about moving from remediation to mitigation? So what are some effective mitigation strategies, and how does the shared responsibility model fit into all that?
I mean, ultimately, we do want to remediate insecure by design issues, but we're also um, just very like adult about the realities on the ground that this might take months or years to fully remediate. In the meantime, we have to acknowledge there's things we can do to mitigate the risks. Cloud service providers can allow their customers to turn off some of this functionality. If they're not going to use it, allow them to turn it off so it can't be used against them. Provide them effective guardrails to be able to, kind of blunt some of the sharper edges of features. And then also make sure that their customers can efficiently detect when these features and these pieces of functionality are being used. And I keep saying, the cloud service provider needs to do this so the customer can. And that's all about the shared responsibility, the shared fate model. Their customers are relying on the cloud service providers to give them the logs, to give them the guardrails, to give them, the switches to be able to shape this functionality in a way that is not harmful to them while we're waiting for the fix, while we're waiting months or potentially years.
That's helpful. What about when it comes to sunsetting insecure cloud functionality? Why is this so challenging?
Somebody once told me that, good APIs never die, they just fade away. Once something's published and out there, people start using it, they start baking it into their capabilities and their functionality. It is incredibly, incredibly difficult to start clawing away back features and functionality from customers, even if it's insecure, even if that capability exposes them to risk. Because it's a hard sell to business to say, stop what you're doing and work on this other thing that's maybe not being actively exploited, but could be actively exploited, and reconfigure your entire approach to doing something. You could potentially make the case for it, but it's going to take months and years, right? It's going to be on the back burner. So that's why it's just so difficult to claw these things back once they're out in the world.
Makes total sense. So can you share any real world examples where insecure by design vulnerabilities have been exploited?
Yeah, the last couple vulnerability reports that I have out are examples of insecure by design, and that's actually what inspired me to write this blog post. There was the issue that still persists of this day to this day of HMAC keys being able to be generated for individual Google users. And these with these HMAC keys, you can access S3 sorry, not S3, uh, storage buckets and storage bucket objects. Um, that all seems fine and dandy, but the insecure by design issue with this is they're not logged. The creation of these keys, the usage of these keys aren't being logged. You can't centrally manage them or revoke them for other users. So there's all of these expected capabilities that you would have with this feature that are just missing. And then the other issue that I highlighted back in September was a transitive access issue with a service agent in Document AI, where one user could effectively use the permissions of a service agent through the manipulation of another service. There wasn't a specific line of code that you could point to that was a problem. Rather, it was the design of this feature that was the issue. It took Google about 6 months to remediate that.
Okay, that's helpful. Well, so then to wrap up, I guess my last question, as cloud services evolve, what steps can both providers and users take to minimize the introduction of insecure by design flaws in future systems?
Yeah, I mean, there's a set of expectations that customers have when they're using a feature. They expect there to be a set of expected guardrails, permissions to control the usage of these features, and effective logging to be able to understand whether or not these features are being used. So, fully vetting a service before it's published is probably the first step that any cloud provider should have. Threat modeling how it's going to be used, how it's going to be abused. And then on the customer side, make sure that any functionality your cloud service provider is introducing you to, you have the ability to turn off and kind of opt out of everything first before you opt into it. And then as you find that you need different features, as you want to opt into them, turn them selectively on, ensure that you have the ability to effectively log all the capabilities. You have the ability to control the different capabilities through permissioning. So just double checking their work, honestly, to make sure that you're provided with the right tools.
That's great. Well, thank you, Kat. Thanks for the perspective today. Like you mentioned, you can like dive deeper into this in the Vectra AI blog, which you can find on our website. I always love chatting with you, so it was great to be able to dive into this topic with you. Thank you, everyone, for joining, and we'll see you next time.
Thank you.